All right, so here's our airplane. Let's just draw it straight level flight. These are stick figures. You know, I'm really great at that. So we have lift that acts that way, which opposes weight. So now they're not exactly over top one another, but for our circumstances, they are today. So if this airplane weighs 3,000 pounds and that weighs 3,000 pounds of lift, then these two forces balance and the airplane doesn't climb or descend. And if the airplane produces thrust that way and the balance matches the thrust, the force matches, then the airplane stays at whatever speed it's on. And these are the four forces and they're balanced. But now we need to look at an airplane when it's climbing. Okay, so in this case, weight still acts straight down. We'll exaggerate just a little bit. We could put a number on if we want to, but we're like that. But lift is generated this way. The reaction is generated that way because the airplane's tilted, right? So let's look and see what that looks like on our viewer. So we're generating lift in the airplane by speed. By the square of the speed. So the speed, the air molecules come across the wing, we generate lift or angle of attack. And what happens is the force is generated straight up to the wing, right? Like this. And then that balances the weight. So, but now what happens when we climb is we angle that backwards, right? So now you've got this situation. So then we have a vector problem to work, right? And a vector is this arrow. And for those of you who don't know or don't care what a vector is, I'll make it a little different color. But a vector, if I just do this with an arrow and a line, the direction that the force is applied is shown by the arrowhead. So we have a force being applied straight up. And the length of this line indicates the magnitude or the strength of which it is, right? So if I were this, I'd just be going, if I were a little ball right here, this would be going straight up. And then if I did this, if I put the vector that way, and the ball were there, you'd be going straight to the right. But if I do it like this, oops, my pen went crazy. Give me a second so I can get rid of my crazy pen. I have a tendency to push this one button on the pen, which is not the best thing. So we did it like that. Now it's going up and sideways. So it's going that way, right? So some part of this vector goes up, and some part goes that way. And the net result is it goes that way. So if I did it more exaggerated, if I put it like mostly like that, then you should be able to see that this goes up very small compared to how much it actually goes sideways. And that's just true. So this is how you resolve a vector.